Hi everybody. Today our topic is refraction of light through a prism. So already you know what is meant by prism. A prism has two refracting surfaces. Actually it is having three rectangular faces and two triangular faces. One of the rectangular face we will consider as a base and the other two rectangular faces which are inclined each other at an angle, and that angle of inclination is called angle of the prism. So let us see the diagram of a prism. We can draw the diagram here. We have a prism. These are the inclined rectangular faces. The bottom face is called the base. This is a base of the prism. And here we can mark the angle of the prism. A is marked as the angle of the prism. So I will draw once again the straight line. The base. This is the base of the prism. So base. These are the faces which are inclined each other. I will mark the name of the corners X, Y, Z like this. So we have a prism. This is one refracting face and this is the other refracting face. Now we will consider a ray of light incident on the face XY. This is an incident ray of light. Let us mark the incident ray as PQ. PQ is the incident ray of light. This light ray will undergo refraction. So it will enter inside the prism, undergo refraction. So we know that the light ray undergo refraction towards the normal. So this is a refracted ray of light. This refracted ray can be marked as QR. QR is a refracted ray. QR. Okay. Now again, here we have to draw the normal. This is a normal. So the light ray is bending away from the normal. This is the refracted ray of light. Or we can say emergent ray. So there are two refractions taking place. One refraction at the face XY and the other refraction at the face XZ. So I can mark the angles as angle of incidence here. Angle of incidence. This I will mark as the angle of refraction R1. Here I will mark as a refraction angle R2. This is the angle of emergence. Okay. So angle of emergence, angle of incidence, refraction angles R1 and R2. So QR is the refracted ray of light and RS is a refracted ray of light on the face XZ. So incident ray and these two are refracted rays. QR is one refracted ray, RS is the other refracted ray of light. Now I will extend the incident ray in the straight direction and I will extend their emergent ray also in backward direction. So they will meet at a point. This point I will mark as O and this point I am labeling as M. Here they make an angle. This angle is called the angle of deviation. Angle between the extended incident ray and extended emergent ray. The angle is called angle of deviation. Now we can mark these two angles. Here I will mark this angle as delta 1. This angle as delta 2. These are the angles delta 1 and delta 2. Here A is the angle of the prism. Delta is the angular deviation. Okay, so we have labeled the entire rays as well as the triangular prism. Now we need to get expression for the prism formula. So first we will write the equation for angle of incidence. So from this figure you can see that the angle of incidence is I. Here also you can see delta 1 plus R1. So delta 1 plus R1 will be equal to angle of incidence I. In figure you can easily understand delta 1 plus R1 is equal to I. So I write I is equal to delta 1 plus R1. Similarly on the other side, angle of emergence is equal to delta 2 plus R2. So I can write E is equal to delta 2 plus R2. Okay. Now I am going to add these two because in the triangle QMR, so you can see the triangle. In triangle QMR, what you can see is There are two interior angles, delta 1 and delta 2. And what about delta? Delta is the exterior angle. So by principle we know that sum of interior angle is equal to exterior angle. Exterior angle is delta. So I am going to get delta 1 and delta 2 from here. From here, what is delta 1? Delta 1 is equal to I minus R1. Equation number 1. What is delta 2 from here? E minus R2. Equation number 2. So this is the equation number 3. Delta is equal to delta 1 plus delta 2. I need to add these two. So while adding, you will get delta is equal to delta 1 I minus R1 plus delta 2 E minus R2. So rearranging the terms, you can see delta is equal to I plus E minus R1 plus R2. Equation number 4. Okay. Now we are going to consider a quadrilateral XQOR. So consider the quadrilateral XQOR. In this quadrilateral, there are 4 angles. Which are the angles? This is one angle. I can mark as angle A. So angle A, angle of the prism, angle A. Or simply I will write A. A is the angle of the prism. So first angle is A. Then other angles are XQO. Next angle. Angle XQO plus angle QOR. And the fourth angle is angle ORX. Angle ORX. We know that for a quadrilateral, sum of the 4 angles will be equal to 360 degree. So we can write this 360 degree. Sum of the 4 angles. But we know that what about these angles? XQO. XQO is angle made by the surface XY with a normal. Since it is made with a normal, this angle should be 90 degree. So I can write angle XQO should be 90 degree. So I will write angle of the prism plus 90 degree. What about ORX? ORX angle also made with the normal. This surface making angle 90 degree with the normal. So that also will be 90 degree. Remaining is angle QOR plus 90 is equal to 360 degree. Okay. So these two angles are 90 degree. Now subtracting, taking this to right side, what will you get? Angle of the prism plus angle QOR. 90 plus 90, 180. When it goes to other side, it will become 180 degree. Subtracted from 360. 360 minus 180 will be 180 degree. So this is equation number 5. Okay, so we have considered the quadrilateral XQOR and we have got this relation. Now we will consider a small triangle QOR. So in a small triangle QOR, what is the relation? Sum of these 3 angles. Which is the first angle? RQO. Angle RQO. Plus second angle QRO. Plus angle QOR. When you add these 3 angles, what will you get? You should get 180 degree. But we know that angle RQO is R1. Angle QRO is equal to R2. So we can substitute here R1 and R2. So R1 plus R2 plus angle QOR should be equal to 180 degree. Equation number 6. So from the triangle, finally what equation we have got? R1 plus R2 plus angle QR is equal to 180 degree. We can compare equation 5 and 6. Comparing, right side we have 180 degree, left side A angle QR. Here we have angle QR, and instead of A what we have R1 plus R2. So generally what we can write, we have the relation A is equal to R1 plus R2. So A is equal to R1 plus R2. This I will give equation number 7. Now we can substitute this here in equation number 4. 7 we can substitute in equation number 4. What will you get? Delta is equal to I plus E minus, instead of R1 plus R2 I will write A minus. Or I will get delta plus A is equal to I plus E. So when you add angle of deviation and angle of the prism, what will you get? It will be equal to sum of angle of incidence and angle of emergence. deviation angle plus angle of the prism equal to I plus E. Now when you do the experiment in lab with the different angles of incidence, we will measure the angle of deviation. And experiment it is observed that when you increase angle of incidence, initially angle of deviation decreases. I will give a few values to understand this. Angle of incidence, angle of deviation. When you do in lab the experiment, it is seen like this, it is observed like this. For example, you take angles like 35 degree, 40, 45, 50, 55. For all these angles, you gradually increase angle of incidence. You can see angular deviation will be large value beginning time, thereafter it will start to decrease 43 degree, 38 degree, then increases slightly 40 degree, 44 degree like that. So initially it will increase, decrease, thereafter it will increase. When you plot a graph with the angle of incidence with the angular deviation, the graph you are going to get will be having a shape like this. Here angle of deviation delta. Delta is angular deviation, this is angle of incidence. You will get a graph like this. A curve will be obtained. The curve has a minimum value for deviation. This deviation angle is called a delta m. What is delta m? Delta m is called angle of minimum deviation. And at minimum deviation angle, we have two things to be noted. That is, at this angle of minimum deviation, I is equal to E. Both will be equal. I and E will be equal. And R1, R2 both will be same. We can give another value R. This will be same. At which angle? At angle of minimum deviation, angle of incidence equal to angle of emergence, and R1 is equal to R2 should be equal to R. We can give another symbol R. Now we are going to substitute it here. At minimum deviation, I can write this equation as delta m is a minimum deviation angle plus angle of the prism is equal to I plus E. I and E having same value. I will write 2i. I plus I, 2i. So what is I from this? Delta m plus a divided by 2. This is the angle of incidence. Similarly, angular refraction also we can write. We know that R1 plus R2. R1 and R2 having same value. So R plus R, 2R is equal to A. So I can write 2R is equal to A. And what is R from this? A by 2. I have got the values of I and R. So Snell's law is familiar for us. In Snell's law, sin I by sin R is equal to what? Refractive index of this glass prism with respect to surroundings. So substituting here sin I. What is I here? Delta m plus a by 2 by R sin a by 2 is equal to n. This is a famous equation known as Prism formula. So Prism formula gives relates refractive index, angle of minimum deviation, and angle of the prism. So this is for a prism light, a prism having a particular angle of the prism, particular angle for the prism. Now there are thin prisms available. Thin prism means prism having very small angle of capital A should be very small in value. In that case, we have a general condition that sin theta is nearly equal to theta when theta is small. So when the value a is small, we can nearly write sin of delta m plus a by 2 nearly equal delta m plus a. We can avoid the sign. Sign function we can avoid. What we can write? We can write instead of sin value we can avoid in both cases because angle values are small for a small angle prism. So how will this equation modify? Equation modifies as delta m plus a by 2 by a by 2 because sin theta nearly equal theta. So theta will only be theta value means these are theta values. Angle values alone we need to write it's equal to n. The 2 in the denominator side, both denominator and numerator 2 will be cancelled. What will you get? Delta m plus a by a is equal to n. Or rearranging you will get n into a is equal to delta m plus a. Or what will be delta m? Delta m is equal to n minus 1 into a. This is the angular deviation for a small angled prism. So for a small angled prism, the angular deviation delta m is equal to n minus 1 into a. For a general prism, we have the relation for refractive index n is equal to Sin A plus delta m by 2 by sin A by 2. This is known as prism formula. So a prism has 6 faces. Sorry, 5 faces. Out of the 5 faces, 3 faces are having rectangular cross section and 2 faces having triangular. You can see one of the triangular face here, other will be back side. And 2 rectangular faces, and this will be the base, third rectangular face. In one rectangular face, light ray enters through the other one, opposite face. Inclined faces are there, x, y and x. Through the other face, light emerges out. This is angle of incidence and this is angle of emergence. Okay, I hope that you have understood. This is the prism formula as well as the refraction of light through a prism. Okay, thank you.